Are you able to see my screen?
Yes, sir.
Okay. Yeah, very good afternoon to all of you. Today I want to touch upon few small points which are related to pointers. The first thing is pointers cannot be used to point to what are called as register variables. Okay. So I have not told you what register variables are. Now in C, when we declare a variable, this is a memory variable. It is stored in memory. Okay. But if I prefix this definition with register, like register int a equal to 5, then this variable value is not stored in memory. Okay, then where is it stored? It is stored in CPU register. Okay, so all of you know the central processing unit of a computer has what are called as registers. In 8-bit processors, we had register A, B, C, D like that. These are 8-bit register. It means they could hold only 8 bits. But when 16-bit processors came, they were named AX, BX like this. So these are temporary storage locations inside the central processing unit, that is a microprocessor. And subsequently, when 32-bit processors came, they were renamed as EAX, extended AX, extended BX like that. So the sizes were increased from 8 bits to 32 bits. Now that we have 64-bit processors, they are again, the names have not changed. They are still EAX, EBX, and so on. So when I say register int A equal to 5, this 5 is stored in one of these registers, maybe in register AX. So 5 is stored here. So obviously when it is inside the processor, it does not have a memory address, and we know pointers can point only to memory addresses. So you cannot use pointers to point to register variables. That you must note. Okay. The second thing is you cannot update a constant pointer. Now we all have seen pointers, but if I use the keyword const before the pointer name, then I cannot do p plus plus. That is obvious, right? What you are saying in the definition is that it is an integer pointer, p is an integer pointer, but it is a constant pointer. It means it can point only to c. You cannot make it p plus plus, or if p points to an array, you cannot go to the next element in the array. So in some cases, constant pointers are required. We don't want these pointers to point anywhere else. So in that case, it is better to use the modifier constant to make it a constant pointer, so that even accidentally you don't increment it or make it point somewhere else. Okay, so these are the two important things with regard to pointers which were to be covered today. Okay, so we shall see in our code demonstration what are these register variables, and the next thing is array of pointers. So just as you would store array of normal variables, you can have array of pointers. That is, if I say int star ptr in square bracket 2, it means there are two pointers, ptr0 and ptr1. Now these ptr0 and ptr1 being integers, you can assign them to some variables, let's say int and a. Similarly, this can be assigned to and b. So these are two pointers in the array which points to regular variables a and b. Similarly, if I define an array of character pointer, that is char star ptr square bracket, then I can make it to point to string constants like this. It means your ptr0 points to the constant string hello, okay, and then ptr1 points to a word, and like that. All right. Now you can initialize an array of pointers using this string constant, but if you want to just define array of pointers, then you can say char star ptr5. It means there are 5 pointers ptr0 to ptr4 which can point to memory locations, and these memory locations can be dynamically allocated. That is, I can use malloc to make this pointers, that is the 4 pointers 0 to 4, to point to some dynamically allocated space. Okay, so using the malloc function, right? So we shall see this part of my presentation in the demonstration, and we shall proceed with other things. So if I go to online GDB, so let's first see how do I declare a register variable. So it's just the same. You just have to use the keyword register int a, and you can initialize it to 5. Okay, so it looks like a memory variable, but if you prefix int with register, this variable a and the value that you are assigning 5 will be assigned to some register in the CPU. Now if I have a pointer, it is an integer pointer, you cannot make it point to address of a, because it is a register variable, it will not have an address. If you try to do that, you will see address of register variable a requested. It means that is not possible. Alright, but if I remove this, the program works. Of course, it doesn't print anything. Just wait for user to proceed, and if you want, you can print that. This is one part. The second, as I told you, you can make this a constant pointer, and here if you make it point to a, you can use this constant pointer to point to a normal variable. Again, it should not be a register variable. So if I say printf percentage d star ptr, you should get the value of a, which is 5. So as you can see, if I run the program, I will get 5. But you cannot increment this pointer. You cannot say ptr plus plus. Of course, we have seen that if I have a variable b here, which is having value, let's say 9, if I do ptr plus plus and try to print, it should print value of b, but now ptr is a constant pointer, it will not print anything. It says increment of read only variable, it doesn't allow. But on the other hand, if I remove this, it is pointing to a now, but if I do ptr plus plus, it gets incremented, it will point to the next variable, which is b. Now we will see the value 9 is printed. Even though it is pointing to a here, it is incremented, and we have seen the memory image of this program where a and b are consecutively allocated, and if I increment the pointer ptr, it will go to the next variable b, and it prints b here. On the other hand, if I comment it out, it will print 5 as before. Okay, so pointer arithmetic is not possible with constant pointers. Is this point clear?
Sir, what happened with the register pointer?
Pardon?
For register, if we declare a register and
Yeah,
try to point that.
yeah, we have seen that if I say register int a, and if you try to initialize the pointer to this variable a, it doesn't allow in the first place. Okay, so leave this apart. Now you will see that you get an error saying that address of register variable a requested, but there is no address of register variable a because it is not stored in memory.
Okay.
Okay, so you cannot assign a pointer to a register variable.
And sir, pointer to a constant integer. Like,
Yeah, that is possible. If I say const int a, that's not a problem. Const int a, and you can point, and it works. Initialization discards const, but it is working now. It is printing 5, but it is saying discards const qualifier. Maybe the compiler will eliminate this const. I do not know why, uh, and makes this pointer point to A. But you cannot change the value of A through the pointer. You cannot say, uh, so if I use int, let us say, we'll use the normal pointer notation, ptr. It can hold addresses of two normal variables. So that is int a equal to 5 or 4, b equal to 7, something like that. And here you can say ptr of 0 holds address of a, and ptr of 1 holds address of b, right? And then you can print through one more percentage d here, ptr star ptr of 0, right? The content of memory pointed to by ptr. So dereferencing must be done. So you used an array of pointers, each pointing to one of these variables, and if you can dereference, you can print them. As you can see, 4 and 7 are printed. So many times you have to use array of pointers when large number of objects are to be processed. Individual values, okay, you use, now there are only two variables, you can use only one pointer and use that. Once you point to A, another point B. But if you want to use both of them simultaneously, then you have to use an array of pointers like this. Similarly, I can have character pointers, let us say names. So here I can initialize them to some constant like Kiran and something like this. So now what is happening is each one is that is names of 0 is pointing to Kiran and names of 1 is pointing to Praveen. So if I can print them here, you will see percentage s slash t, percentage s slash n, and you can have names of 0, names of 1. Okay. So an array of pointers are sometimes useful. That is, you can make them point to an array of strings, and you want to process each one of them. Maybe there are some commands in a shell where you want to do ls first, then you want to do, let us say there are commands like this. You want to perform an ls command on Unix, and then you want to perform, let us say, more command. So these two can be processed one after the other. So as you can see, those two commands will come. If you have more than one, suppose normally there will be a pipe symbol in between like this, and in that case you have to have 3 pointers here, and in that case you have to print the middle one also with a slash t, percentages, and names of 1 and name of 2 also. So now you will see that ls pipe more command will come. So there are many occasions where you have to store an array of strings, and it is better to define an array of pointers like this. If I am not initializing the strings array of pointers with the strings like that, then in that case, for example, all names, I take one more variable, let's say 3. So there are 3 pointers. Okay. Here I am not initializing these pointers to anywhere. They are hanging pointers. All names of 0, all names of 1 and 2, they are just hanging. They are not used anywhere. Now you cannot say uh, all names of 0 uh, assigned to some string. This is not allowed because there is no memory to store Ajay. It is only a pointer. Normally we do a string copy, right? String copy of this and with the string. You cannot do this because this is a pointer and you are giving a string. So there's where do I store this Ajay? So memory should be allocated to each pointer. Okay, so what I have to do is I have to use a for loop here, or you can do it step by step. Let us say we have a for loop I equal to 0, I less than 3, I plus plus. What I have to do is all names of I equal to malloc some 20 characters, let us say. So the names which I'm going to store will not be more than 20 characters. So now the memory is allocated. You can use all names of 0 as this, and then you can put some more names here, some names. So now only after allocating memory to each of these character pointers, you can string copy and the names are stored. Okay. And if you want to display all of them, again put a for loop I equal to 0, I less than 3, I plus plus. Here we can do a printf, percentage yes should come here, and then just all names of I. And if you want to print all of them on the same line, just put a slash t. And before that, possibly you can, yeah. Now we'll see Pritham Suraj has come here. Where is it?
Line 25, it should be
Yeah,
2.
it should be 2 here, yeah. So it is throwing this error because we have used string copy. I have not included string.h. If I do that, string.h. Similarly, when you use malloc, I should include stdlib.h. So all the errors will go now. So you will see Ajay Suresh Pritham has come. Of course, this less more is also getting displayed. If you want to push it on to next line, you can put a printf here. Yeah. So now you see Ajay Suraj Pritham is coming. That earlier less more command is also coming, and your 4 7 is also getting printed. Okay. So these are some finer things that you should be aware of. How to use pointers, how to use array of pointers, and what care you should take while using pointers. That is, you cannot make pointers point to register variables, and if it is a constant pointer, you cannot implement it. Okay. So just try this out. So initially, you declare a sentence, which is an array of characters, and don't forget to leave a space here because you want to count the last word also, and use some indices I and j to keep track of characters in the sentence and also characters in the individual words. And you declare an array of 6 or 5 pointers which eventually point to the individual words, and you declare one array of 10 characters for recording individual words and later copying into the array of pointers, and dynamically allocate space for each of the words in the array list. So each pointer in words will point to 10 characters. So the while loop will take you through each character till you reach the end, and within the loop you check whether you encountered a blank space or not. If not blank space, copy that character into the word and proceed, and if you encounter a blank space, then you terminate the word with null, increment the index I. This is where the program was going wrong. And once you get the entire word into the variable word, copy it into the array of pointers. Observe WC is a word count pointer or word count variable which will keep track how many words are there in the sentence, and it will help you to reach out to one of the pointers in the array of pointers, and you have to reset the value of j before you loop back after you encounter a blank space. Next word when you copy, it will be copied into the word variable right from the beginning, and when you come out of the while loop, you will have all the words in your array of pointers. Iterate through them. So if you don't increment I in the else part, the while loop will never complete. That is why we are not getting any output there, isn't it? It will not reach /0. You all are able to see the screen? Hello?
Yes, sir.
Okay. Yeah. Now, there are a few library functions which you have not seen earlier, and these are also important to know. So there is a function called as getchar. That is, it waits for you to enter the key and then proceed. And there is a another one getch. So it doesn't wait for you to press enter. It will read the character whatever you typed and it will proceed. And there is a put char to put one single character on the screen, and also put C on the screen without waiting. So these are some of the functions which you may have to use. For example, you have displayed a menu using switch statement, and you want to read the user choice. So choice can be a single character. In that case, you can use getchar. Okay. And if you want to read entire string, then it can be getch. But getch is little dangerous. It doesn't check the array boundaries. That is, you have to specify an array of characters name. So if it is 10 characters and if you enter 15 characters, it will not check the boundary and buffer may overflow. So you should not use getch. Instead, use fgetch. So in fgetch, what is done is, as before, the name of the array, character array has to be specified. Here you have to specify the size of the array. If you try to enter more than the size of the array, it will throw an error. And you must mention whether you are reading from a file or from standard input. So you just say choice. You can store a character in integer variable or character, because we know that any character is ultimately converted into choice equal to getchar. So it will wait for you to enter something, and then you say printf percentage %c, you entered percentage %c, like that. It is waiting for you to enter something, let us say t, and even if you enter t, it will not proceed further. Okay, you have to press enter key, only then it will give you enter t. Okay, on the other hand, if it is getch, here you have to give std in the standard input. It will not wait for you to press enter, so that it will check the size of the input that you're entering. So if I say hello world, so entire hello world 11 characters will be stored, and you entered hello world will come. Okay, so getch should be avoided because it doesn't check the size of the array that you're given. If you give enter a sentence more than 20 characters, the buffer overflow will happen, and what you print will be containing a lot of garbage. Whereas if you use fgetch, it will check the size of this and it will limit to whatever size that is given. What is left in C programming is the files. So to open a file, you should declare a file pointer. Okay, and to open a file, you have to use fopen library function. And here you can give any file name, for example test.c, something like this, and you can open this for read mode or write mode. Since I don't have any file here, I'll open it for write mode. And is it yeah, printf, yeah. So as you can see, I should have used fprintf, and in test.c that hello world is printed. Okay, so fwrite is for writing a structure, not a string like this. So now if I write something else, hello world, how are you? Okay, so fprintf will overwrite. Okay, so if I run this again, okay, so I should not rename it as test.c. It will try to compile this file also. Okay, so I got it now. 1 minute. Now if I say test.txt, it will work fine. So you'll see this, and again if I overwrite with something else, slash and not a good day. If I run this, yeah, that is also coming, isn't it? So the mistake was when I was using test.c, it was creating test.c, and when you compile, it will compile main.c and also test.c. So test.c doesn't understand hello world has a syntax of any C program. So it was giving you that error. But now I renamed it as test.txt. Now if I append, already test.txt exists, and if I put something else, let us say learning C is painful sometimes. Okay, so it should get appended, right? Now if I run the program, you will see that learning C is painful is appended. So it did not overwrite. Okay, so if I change it to W now, you will only see learning C is painful. The earlier thing will be erased. So if I go to this file, you will see only learning C is painful sometimes, isn't it? So you can open a file and open this in read mode or write mode or append mode. So there are three modes here. Three modes: read mode, write mode, and append mode. So depending on the requirement, you have to do this: read, write, or append. Okay. Similarly, whatever is there in the file, you can read and print it on the screen. Now you already written this file, right? So you can use read mode. Don't write anything. So what you can do is while f get c fp not equal to end of file, you can use put c std in std out, store that in some character. No, so I will take character c. So whatever you read, you store it first and check whether it is end of file, and if not, you print that character to standard output. Okay, so hopefully this will, yeah, as you can see, it is printing learning C is painful sometimes. So what am I doing? I am opening the file in read mode and then reading each character using getc, and if it is not end of file, so end of file is a no particular code which is defined in some header file. So it will compare with that. If we have not reached the end of the file, it will put that character on the standard output and go on till the end of the file is reached. So end of the file is somewhere here. Okay, so you can write any number of sentences and you can check. For instance, if I go and edit this, uh, check if it is reading next line also. Okay, so let's see whether this happens. As you can see, check if it is reading next line also. So it is reading both the lines. So till the end of the file is reached, it will keep on reading. Okay. So just play around with this. Open a file in write mode, write something there, and again see whether the file is created, and read that same file in read mode. If you only want to try this, you can add a new file, call it as text.txt. You only type something and read it directly and try to print. Okay, to summarize what we discussed today, we looked at pointers, a few of the limitations of the pointers. The pointers cannot point to register variables, and you cannot do pointer arithmetic on constant pointers. All right, array of pointers. So array of pointers to integers, array of pointers to strings, and we saw one concrete example of how array of pointers is useful to store all the words of a sentence. And then we saw some library functions like getchar, getch, and getS. GetS is not advisable because it doesn't check the array size. You must use always fgetS instead. And C also supports opening the files in read mode, write mode, or append mode. When you open the file in write mode, whatever is the original content will be overwritten. But if you use it in append mode, it will help you to write to the file, but whatever that exists before writing will be maintained. It will append to the existing content. All right. And we saw one example where we are reading a text file, and till the end of the file, you read by reading each character at a time and then put it on the standard output. And you must close the file. Otherwise, there will be a lot of resources held up, because when you open a file, a lot of data structures are used internally. They will all be data structures if you don't close the file before you exit the program. So it's a good practice to close the file before you exit. All right. So we shall see more of these files. We have only seen text files. So there is another type of file called as binary files. So what are the scenarios where you use binary files? Especially when you use structures and you want to write a structure or an array of structures into a file. Opening the file in binary mode would be more useful, and you can efficiently store the data and also read the data from the binary file. So more on that we shall see in our next.